Hi everybody, in the previous videos we have covered all the topics from unit number 1. Now it's time to proceed with the unit number 2, that is computational thinking and programming part 1. From this unit we will be covering introduction to problem solving. Then without further delay, let's get started. Alright, these are the topics we are gonna revise. The first is problem solving cycle. To solve problem, we are gonna use the concept of decomposition, followed by the topic algorithm. Then we will discuss flowchart. Finally, we will get an idea about pseudocode. To solve any problem, it may be small or it may be a big, we follow certain steps. That is called as problem solving cycle. What are those steps? The first step is to understand the problem. We need to find out the solution for the problem. For that, we must first understand it. That's why we analyze the problem. Then ultimately, here is the second step to find the solution. We are using programming language. That's why we will code the solution. Simply we cannot keep the code. It should work, right? For that, we need to perform the testing, and if there are some errors, we need to debug it also. So in all, here are the steps we will be following. First we will understand the problem, what exactly it is. Then we will analyze. In that we generally decide what are the requirements. Then we will design the solution, code the program, we will test and debug. Testing is important. As we have developed the solution for the problem, we write and keep it. It is called as documentation. And that code should work for a longer period. That's why we need maintenance also. There are different ways for problem solving. The one is decomposition. What is this decomposition? We break down the bigger problem into a smaller one. Let's take one simple example. If you want to prepare for exam, what you will be doing? You will decompose that task or you will break down the task. How? Generally, we follow these steps. We list all the chapters or topics we need to cover, then we make a schedule for it. If it is a big chapter, we break down into subtopics, and to go through that subtopics, we generally read, we make notes, we solve examples. And we know that after completion of all the subtopics, we do the full revisions, we solve some sample question papers. If we follow certain steps, our preparation will be in a systematic manner. You can take one more example if you want to prepare something. First we need to decide what we need to prepare, right? Then we will find out the ingredients. After getting it, we need to start the preparation. We will wash, cut. If there are many dishes, we need to prepare that separately as a subtask. Then we will be serving it, and don't forget to clean up everything. Try to make that dish tastier. So you now understood, right, how we break down the problems or decompose the problem to find out the better solution. Now the question will arise, how to write that solution. For that we follow certain concept. The first is algorithm. It is nothing but a set of steps. Generally we decide what will be the input, what will be the processing and the output. We will discuss some examples in a while. Now let's move to the flowchart. After writing the algorithm, which is nothing but a steps in a simple English language, we will represent that solution in a pictorial format. That is called as flowchart. So what is flowchart? It is a pictorial representation of steps. We follow certain format to write the algorithm, then we need some symbols to represent it, right? So for start and stop, we use oval. For input and output, we use parallelogram. For processing, rectangle is used. For decision, we use rhombus. To connect all these symbols and to represent the flow, we use arrows. To understand how to write algorithm and how to draw a flowchart, let's consider one simple example. Our problem is to add two numbers. So here are the steps to find out the solution for the problem. Always the first step will be start and the last step will be stop. We follow the principle of input, process and output. So here is the input. We need two numbers. The next step is processing step. We are adding them. And the final step is output. We are printing the result. Now let's try to draw the flowchart. Oval is represented by start. Parallelogram is used for input. For processing we use rectangle. Same symbol, that is parallelogram, is used for output. For stop, obviously we will be using oval. So here is how we write the steps and we represent it in a pictorial format using flowchart. Here is one more example where you need to calculate area and perimeter of a rectangle. Pause the video and give it a try. That two examples were simple one where we followed the concept of IPO. Here is the third example where we need to find out the larger of two numbers. In this example we need to take decision. So here is how the algorithm will look like. The first step and the last step will be same. Here is the second step to take the input. In the third step we are taking decision. If A is greater than B, then A will be larger, otherwise B will be larger. How to write the flowchart for the same? These two steps you know. For taking decision we use rhombus. There will be always two options, true or false, or you can say yes or no. If A is greater than B, then what we need to do, that we will be doing on the true side. If that condition is evaluated to false, we will be writing the statements on the false side. And look at the steps. Finally, it is stop. So from both the ends, we will come to the stop. So to practice decision making, here is one more example to check whether the number is even or odd. So give it a try. If you want to get an idea how the questions will be framed on this topic, make sure to check out this video in which we have discussed some of the important questions. And for detailed explanation, here is the video. Generally, we do the repeated task from morning to evening. Or just you can think of this example. When mother prepares chapati, she follows same steps to prepare chapati. That is called as loop to represent repeated task. So here is a simple example where we need to print numbers from 1 to 10. Look at the steps. Here is start and stop. For that we use one looping statement called as for loop. It will start from 1 and it will go up to 10. We execute loop using one variable. That variable we will be printing. So we will get the values from 1 to 10. How to draw the flowchart for the same? Here is start. Then we are initializing the value of I to 1. That is the starting value. It is nothing but 1. Then we are using decision box to check whether that value is less than 10. If it is less than 10, we will be printing it. In this way we got the output as 1. Then we will increment it by 1. Because the next value we want 2. Again we will check whether it is less than or equal to 10. If it is yes, we will print it. It will get incremented, then it will get checked and it will get printed. This same process will get followed until the value of I becomes 10. When the value of I will be 11, this condition will get false and we will stop the process. In this way we will get the values from 1 to 10. To practice loop, here is one more example in which we need to calculate the sum of n numbers. If we consider n is 10, we need to calculate the sum of first 10 numbers. So pause the video and try it yourself. We are proceeding to the last topic, that is pseudocode. We understood that to write the solution for the problem, the first step is to write algorithm, then second step is to draw flowchart. Now what's this pseudocode? Pseudocode is just like algorithm, but in algorithm we follow certain rules how to write the solution. But in case of pseudocode, you need not follow any rules. That's why it is called as informal way of describing the steps. It means the way you want, you write it. Let's take one simple example. If I want to add two numbers, how I can write this pseudocode? I am writing the steps in a plain English. You can write it in your own language too. That I am taking first number, I am taking second number, we are adding it and we are printing it. You can see here there are no strict rules. I am not writing start, stop. I am just mentioning the steps in an informal way. And here is the pseudocode for larger of two numbers. So pseudocode gives you a liberty to write the solution in your own language, in your own ways. But make sure that you and others can understand that solution. So in this way, we revise all these topics: problem solving cycle, decomposition, algorithm, flowchart and pseudocode. It's a theoretical topic, so read the definitions carefully. When we will start Python programming, you will understand this algorithm and flowchart in more clear way. With the hope that you have understood all the concepts, it's time to wind up today's video. In case of any doubt, let me know, and don't forget to like, share and subscribe. In the next video, we will be proceeding with the basics of Python programming. So until next time, keep practicing. I will see you in the next video.